All right, we are on 11.8C, and we are going to learn how to rationalize the denominator. Okay, so I'm on page 818 in your textbook, and I just want to review before I even get into examples what this rationalizing the denominator means. So as a quick review, the denominator is the bottom of your fraction. And what we have to do is you're actually not allowed to have a radical, any kind of radical, square root, cube root, fourth root, whatever the root may be. You can't have this radical symbol in the bottom, in the denominator of a fraction. So today we're going to talk about how to get it out of there if it happens to be there. All right, so again, page 818 in your textbook. I'm in example 4a, and I am starting with the square root of 7 over top of the square root of 2. So again, we can't have this guy in the bottom, so I am going to rationalize. So what you do is you take the square root of whatever this is, and you multiply top and bottom. Now, I'm allowed to do that because that simplifies to 1, and you're allowed to multiply anything you want by 1. So let's start with the numerator. Both of these are underneath your radical symbols, so they multiply together. I have the square root of 14. In the denominator, both these numbers are underneath your square root. So again, I'm going to multiply them together. And I get the square root of 4. And you're jumping for joy at this point because you love math. And you recognize that this is a perfect square. So the square root of 4 is 2. So you have rationalized the denominator. There are no perfect squares that go into this 14. So we leave it as the square root of 14. And that guy is your answer. All right, example B in here. We have the square root of 7 over top of the square root of 8n. Now, right off the bat, I'm noticing that this 8 has a perfect square that goes into it, so I should simplify it. So 4 times 2. All right, so the square root of 4, that will come out, and I'm rewriting this denominator as 2, because again, I took the square root of this 4, and then I have 2 that's left over, and then this n is not a perfect square, so it's staying underneath. Okay, and I have not done anything with my numerator, the top number, so leaving it alone. Now, like we just did on the previous example, you are not allowed to have a radical in the denominator. So you take what that radical is, and you multiply it to the top, and you multiply it to the bottom. So let's deal with our numerator first. 7 times 2n gives me 14n, and it's underneath your square root because they both were to begin with. Okay, on my denominator, I look at these two pieces, and I'm going to multiply both of those because they're underneath your square root. And 2 times 2 is 4, and n times n is n squared. So that's what's underneath your square root right now. Now, I haven't forgotten about this guy out here, but let's just hold on to him for a second. The square root of 4n squared is 2n. So I have now simplified that. Now I'm going to multiply it by this guy that's out in front, my coefficient. So 2 times 2n gives me 4n. And I've simplified. I'm totally done at this point because there's no perfect squares that go into 14n, and there's nothing I can simplify. Now, that might seem like a lot, so let's try 2 more examples. Actually, 3 more examples for some practice. So our first one was the easy type. You have the square root of 5 on the bottom, square root of 13 on the top, and we need to rationalize this denominator. So I'm going to multiply the top by the square root of 5. And I'm going to multiply the bottom by the square root of 5. All right, 13 times 5, because they're both underneath your radical, gives me the square root of 65. On the bottom, you get the square root of 25. When you multiply these guys together, you get excited because you know that the square root of 25 is just 5. There are no perfect squares that go into the square root of 65, so we leave it as the square root of 65. All right, number 2, this is the one where we have to be a little careful because this 12 that's in the denominator has a perfect square that goes in there. I'm going to write it as 4 times 3. Now, the square root of 4 is 2, so that comes out, and your 3 stays underneath. And I am not doing anything with my numerator, so just rewriting it as the square root of 7a. All right, here comes the rationalizing part. So we have this guy right here that we need to get out of the denominator, so I'm going to multiply the top and the bottom by that radical. So in the numerator, these guys multiply together because they're both underneath. So 7 times 3, that gives me 21, and it's got the a with it. All right, bottom, this piece right here, that gives me the square root of 9, which we know is 3. Now don't forget that 3 and this coefficient of 2 need to multiply together, and that gives you 6. There's nothing else to simplify because 21 doesn't have a perfect square that goes into it. All right, and our last example for this lesson. All right, looking at the denominator, there's no perfect squares that go into this 7, so we're good to go. But I don't like dealing with big numbers, and I know that there's a perfect square that goes into 80. So looking at this 80 right here, 16 times 5. So I'm going to simplify this. Now, the square root of 16 is 4, so it's going to come out and multiply by this 2. So I really have 8 square root of 5 on the top. And again, we haven't worked with the denominator yet, so I'm just leaving it as the square root of 7. Okay, here comes our rationalizing part. So back to what we've been practicing before. So since I have the square root of 7 on the bottom, I'm going to multiply top and bottom by the square root of 7. So let's see, what do I have now? These guys multiply together because they're both underneath the radical. So 8 is staying outside because it was outside to begin with. 5 times 7 is 35. And then the bottom, the square root of 7 times the square root of 7, we know is the square root of 49, which simplifies to 7. All right, so now you've seen 5 different examples about how to rationalize the denominator. For your homework tonight, you are on 11.8C. You're still on page 819. 19 through 25, you are practicing all of that rationalizing that we just did. Okay? 39 and 41, we're going to go back and review foiling, which is what we did in the previous lesson from 11.8B. And then our last ones, 45 through 49, you're going to go back and practice your rationalizing. Okay, please be sure that you are showing your work. I'm going to write that. Oh, show work. There's no way you can do these in your head. Okay, show your work. And then don't forget you can check odd answers in the back of the book. So make sure we are doing that as well. All right, good luck.